Yeah, hello everyone. So let's start our session. So this session will be like our previous Verilog interview session. So please try to give the answers. So if you don't know the answer, also just try to give the answer. We will discuss the answers also. Wait a minute.
and which makes simulation faster.
Mm-hmm.
Yes.
Any other answers?
Yeah, hello.
Yeah.
Yeah, actually, in two state, there is only two possible values we can infer in our design. That is like if we want 0 and 1,
Mm.
X and high impedance will not be there for two state data type.
Okay.
If suppose there is any design where we want to use that like only 0 and 1, and we are not using any tri-state buffer kind of thing, then we will use two state data type.
Yeah.
So that is bit and all.
Yeah. So any others want to give the answer? Yeah. So uh, the name only suggests that two-state data types. It can store only two values, zeros and ones, and it cannot have X or high impedance. It can only store two values, that is 0 and 1. So my next question is, what happens when we try to assign unknown or Z values to this two-state data types? What's the value?
It will become for state logic kind of things. If suppose any structured false or any meta stability condition or some uh, means our simulator doesn't know whether it is 0 or 1, then it will obviously go for unknown value. Otherwise, if we have any undefined variables like open wire, then it will go to for high impedance like Z.
Okay.
That time we will be, so if any designer required all that such conditions in their design, so it will go for four state.
So
So
my
it will
question is,
declare like
what happens when we assign unknown or high impedance value to a two-state data type? So when we display the value of A, what will be the value? This is the question.
okay, then it will go for 0 and 1 only.
Okay. Any others?
So
Yeah, you are correct. So when we try to assign unknown or high impedance value, so it will only assign to 0 or 1. Next, what are the examples of this two-state data types? Give some examples of this two-state data types. Examples of two-state data types. Any answers?
Long, short, integer.
Okay. Others? So the examples of two-state data types are bit, byte, int, and shortend. So they can have only two states. Now, my next question is what is meant by this logic data type and how it is different from reg data type?
This long int is not the part of toState.
Yeah, sorry, long int is also basically all types of int.
Okay, okay.
Yeah, my next question is what is the difference between the logic data type and reg data type? Any answers? Okay, so this logic data type and rig data type both are, first of all, four state data types.
Can I say
Yeah,
something?
yeah, yeah.
Yeah, actually, uh, it is a same kind of family, four
Okay,
state and unsigned variable,
okay,
and I think it is user defined data type. But the for according to me, only different is that if we are assigning any res kind of data type, so that there it is like in initial procedural block we have to define it.
okay,
But when it's come to logic data type, there is no such condition whether it is continuous assignment statement or it is procedural statement.
yeah,
So we can define it for universal, like for our thing.
yeah. Any other answers? So the logic data type is a four-state data type, and a reg data type also is also a four-state data type. So it can have 0, 1, x and z, and it also have 0, 1, x and z. And the default value of logic is also unknown, whereas reg is also unknown default value. And logic data type can be used with procedural assignments as well as continuous assignment statements, meaning it can be used with initial, always, as well as assign. So it can be used with all this type of statements, whereas reg data type can only be used with procedural statements only. It cannot be used with continuous assignment statements. So it can be used with always, or else it can be used in initial blocks. It cannot be used with assign keyword. So this is the difference between the logic data type and reg data type. So my next question is here there is a snippet module, example logic A B C. So can an always block begin? Okay, I will use an initial block here. Initial begin C is equal to A plus B N, and assign C is equal to 1, ending the module. So what is the value of C? Any answer? Take your time.
One.
Okay. Any other answers?
But sorry, not one. It will be okay. We have not declared any value. It should be previous value. It will take. Then it will take the. It should be x
Mm-hmm.
unknown.
Okay. I will write here c is equal to 0. Initial begin c is equal to 0 and assign c is equal to 1. Ending the module. Any answers?
Now also our simulator should not be knowing that what the final value it will be. So I think it will throw it if it is logic type. It will throw x only.
Okay. Any other answers? Yeah. So since the variable c is used in procedural assignment, it is a logic. So the variable can be used in both a procedural as well as continuous, but the same variable is used in both the procedural as well as a continuous assignment statements. So the value will be unknown. C will be equal to unknown. Simulator will not know the value of C since it is used in both the assignments, both procedural as well as continuous. So the value will be unknown. So my next question is, what is the difference between the packed arrays and unpacked arrays? This is a very frequently asked question. Take your time and try to answer.
Packed array.
Hmm.
Packed array refer to the dimension mentioned before the variable
Mm-hmm.
or object name,
Okay.
and it is also known as vector width.
Mm-hmm.
And, and in unpacked array,
Mm-hmm.
refer to the dimension mentioned after the variable or object.
Okay.
In this, memory allocation may or may not be used.
Mm-hmm. Any other answers? So in case of packed arrays, the memory allocation takes place in a single memory location. Like this, all the elements will be stored in a single uh, location. Whereas in case of unpacked arrays, separate memory locations will be created for each element like this. And in case of syntax, if we want to represent, then say suppose data type followed by the size of the packed array followed by name of the array. Whereas in case of unpacked array, the data type followed by the name of the array followed by the size of the array. This is a difference in case of syntax. And this is a 1D array, this is also a 1D array. And if you want to use a 2D array, then the data type followed by 2 dimensions followed by the name of the array. In case of here, data type followed by the name of the array followed by the 2 dimensions. So these are the differences between the packed arrays and unpacked arrays. Now my next question is, what are dynamic arrays? Any answers? Okay, so I'll explain it. So dynamic arrays are the arrays where the memory allocation takes place dynamically. So here in case of dynamic arrays, the memory allocation takes place dynamically. That is, there is no need to allocate the memory, or there is no need to declare the size of the memory before the compile time. There is no need to declare the size of the memory before the compile time. During the runtime, we will declare the size of the array with the help of the keyword new. So with this keyword, we will give the size of the array. So the memory allocation of the dynamic arrays takes place during runtime. So this is a very important point, this we have to mention. So the size of the, so the memory allocation of the dynamic arrays takes place during runtime and not during compile time. So the normally we will declare the size of normal arrays during the compile time, whereas in case of dynamic arrays, we will give the size of the array during the runtime. And the syntax of dynamic array is array data type followed by array name followed by empty brackets. So the memory size is given during the runtime with the help of keyword new. So this is the dynamic arrays. Is this clear? Now what is the answer for this? Index value of green.
0.
Index value of green.
1.
Yeah. So if we declare any enum data type like this, so the index value will be of red will be 0 and green will be 1 and blue will be 2. Now what is the index value of green? Any answers? So the index value of green will be equal to 4. Here the index value of red is equal to 0. Since we are modifying the index value of blue to 3, then the consequent index value of green will be changed to 4. Like this it will get modified. Is this clear? So in this case what will be my output? Any answer? Any answer for this? So we will get a compilation error here. Since we know that in case of enum data types, we can only allocate the values to this variable which we have declared in this list. So since we have declared only orange and black, so we cannot assign a to green, so we will get a compilation error. So like this we can create our enum data type. Now one more last question. What is the size of a? I've used typedef int ca. What is the size of a?
32-bit.
Yeah. Any other answers? So the size will be 32 bits. So we are using typedef. So instead of writing int every time, we can use c. So if we use ca, a will be of type c, that is nothing but int. So the size of int is 32 bits. So like this, the size of a will be 32 bits. So yeah, these are some of the questions. So still there are some more questions we will discuss in next session. So yeah, that's all for today's session. If you have any doubts or queries, you can ask me, or else we can end this session. Thank you.